Once in a while, Death and its cousin Sick feel lonely and want to invite people to the land of disease and death by sending out forceful messengers, viruses, this time the COVID-19 or coronavirus disease of 2019. The corona of the virus, so-called the spike proteins, infect host cells by drilling in. With antigenic activity, it can stimulate our immune system to produce antibodies and develop memory B cells, which could identify and order attack if the body is infected with COVID-19. However, this process may take days, so it's best to warn our body beforehand. Dedicated researchers have made major breakthroughs in finding creative ways to help us duck the invitations. Like some of you, I was also really concerned, mainly because I didn't know the pros and cons of the several newly developed COVID-19 vaccines. So let's take a closer look at how they work. First up, the COVID-19 mRNA vaccine. Messenger RNA transfers the genetic code of the spike protein of the coronavirus into our cells, instructing them like a recipe book. But instead of making cookies, they will produce antigenic spike proteins like these. Since only the spike protein is produced, they can't do actual harm to our body. However, fragile mRNA would dissolve immediately in our body, so scientists have spent decades and recently found the right shield, lipid nanoparticles, for the messenger RNA so that they could actually deliver the message safely before being severely attacked by our enzymes. Similarly, the COVID viral vector vaccines work by having a carrier around the COVID-19 spike genes. This time, it's the adenovirus. It's like putting a COVID-19 spike protein recipe into a body of a common cold-causing virus. But the adenovirus is inactivated, so it can only instruct our cells once. And again, our cells will make some harmless antigenic spike proteins. Lastly, our good old friend, the COVID-19 inactivated vaccines consist of COVID-19 that are sterilized, so that they can't replicate nor infect individuals with COVID-19. But the spike protein and antigenicity still remain. Now that we know how they work, how efficient are they? The mRNA vaccine shows the most effectiveness in preventing symptomatic infections. Then the viral vector vaccines and inactivated vaccines follows. However, all three types of vaccines shows 100% effectiveness at preventing severe diseases. But would the vaccine still be effective if the cunning messengers of death and sick make some changes? Luckily, yes. All three types of vaccines shows a really high degree of effectiveness, ranging from 80% to 95% on virus mutations. But the highest level of effectiveness comes with relatively the greatest side effects. People who are allergic to any part of the vaccines or have an allergic reaction within 30 minutes of the first dose should not be further vaccinated.